Number 17, find the surface area. Find the surface area of this right rectangular prism, basically this big box. So how do we find the surface area of this big box? We have to break it into 6 different sides. Let's start with the right side here. So here's the right. So I'm going to start with the right side. And what's the right side? It's 5 times 3, which is 15, plus the left side over here. That's going to be the same, another 15. And then we can do the top. Doesn't matter what order you do these in. The top, what are the dimensions on the top? Well, this is 7 back here, and this is 5 here. Can you see that? That this is the same as this. They're both 5, and this is the same as this 7, so it's 5 by 7. So it's 35. And the bottom's going to be the same, isn't it? Down here. Bottom is also going to be 35. And now we got the right and the left, the top and the bottom. What do we have left? Let me mention that we have the front. There it is. There's the front. And the front is 7 by 3. Right? This 3 here is the same as this 3 here. So that's 7 by 3. 21, and the back is exactly the same. So add all those up. Just use your calculator. That's 30, that's 70, that's 142. 142 square centimeters, because it's area. Area is always square units. 142 square centimeters. So when you need to find the surface area of a box, you just do the 6 different sides, which are all rectangles, right and left, top and bottom, front and back. On to number 18. Find the surface area of a sphere. Well, the surface area for a sphere, the formula is 4 pi r squared. You just need to have that in your notes when you take the exam. So it's going to be 4 pi, and what's the radius? That is the 5 here, squared. That is the radius, because that goes from the middle to the edge. That's the radius. Now, on the actual exam, I might give you something like this. I might show that all the way across is, I don't know what, 20 or whatever. What if I showed you all the way across is 10? Then the radius would be half that, would be 5, right? So the radius always goes from the middle to the edge. So if they give you all the way across, you got to cut it in half when you plug in the radius. So hit the buttons on your calculator. You're going to get 4 times 25, 100 pi. 100 pi, and that is square centimeters. That's my pi there. It's not looking very good. There we go. 100 pi square centimeters. Right circular cone. So for a right circular cone, again, you're going to have the formula right on your notes for the exam. It is the bottom part, right, this bottom, and that's just a circle. So that's just pi r squared. We know the area of a circle. Plus, we have the sides, all the way around the sides of the cone. And what are the sides of the cone going to add up to be? Well, there's a formula, pi r l, where L is this length here. It's that slant. The L is the slant height. It's not the real height. The real height is the 3. That's the actual height, because that goes straight down to the ground. That's the real height. But the one that goes down the diagonal, L, we call it L, and it's the slant height. So that's the formula for how you find the area of the sides. It's pi RL. That'll give you all the way. That's not just one side. That's all the way around the outside of the cone, pi RL. So, okay, so let's figure this out then. This is pi. The radius is the 4 here, because that's from the middle to the edge of the circle. The radius is 4. Pi 4 squared, and then pi r, again, the radius is 4. L, now we don't know the L. We don't have it. So we're going to have to go find the L. How do we find the L? Well, this is 3. This is 4, even though that 3 looks bigger than that 4, doesn't it? And then this is the L over here. So that's a right triangle, isn't it? You can see this little right triangle right here. So you know when we have a right triangle, a squared plus b squared is c squared. Which one's the c? The one across from the right angle. This is the c, the L. So that's your L squared. And the a squared and b squared are the 3 squared and 4 squared. So 9 plus 16 is L squared. And that's what? 25 is L squared. My L's don't look so good. And then last step, you square root it. So L equals 5. Or I'll put it over here. L equals 5. So the length of this side over here, the slant height must be 5. So plug that in. We do all that work so we could find the L and plug it in. It's the L right here. So what do we have then? This is going to be 4 squared is 16 pi. 4 times 5 is 20 pi. Those add up to be 36 pi square centimeters. That's the area, the surface area of the cone. So remember on the exam, they could put the cone on something and you wouldn't have the bottom then. So make sure you're clear that there's the sides, which is pi RL, and the bottom, which is pi r squared. Those are two different things. On to number 20 here. So on number 20, we are finding the surface area of a right square pyramid. So surface area of a right square pyramid. So how do we find the surface area of a right square pyramid? Well, first off, we have the bottom. Let's do that. What's the bottom? So whenever we do surface area, now we have to take all the surfaces, all the sides, the top, and the bottom. This one has no top. It's just got a point at the top. It's got sides and a bottom. The bottom is a rectangle, so it's just one side times the other. Notice it says square, so the bottom's actually a square, which means the two sides are the same. And what are they? Well, this side is what? 1.5 and 1.5. In other words, all the way across must be 3. This must also be 3 because it's a square. Same dimensions. So the bottom is 3 by 3. It's 9. All right, now what are the 4 sides? Well, each side is a triangle. So we draw the triangle in here. There's the triangle. And so what's the area of a triangle? So we're going to have 1/2 base times height. 1/2 base times height, because that's the area of a triangle, times 4, because there's 4 of those triangles around the sides, aren't there? That pyramid has 4 triangle sides. So it has a 1/2 base times height 4 times. So now what is base and height? Well, this is the base right here. The base must be 3. That's the base of the triangle. What's the height? That's the 5.5. Now, how do we know that's really height? Well, you can see that height goes from the tip top straight down the side. Now, you might say, well, that's not straight down the middle of the pyramid. You're right. It's not the height of the pyramid. The height of the pyramid would be right here at a right angle. That's the height of the pyramid. But that's not what I'm trying to find here. This height here is the height of the triangle side, of each of those sides, right? So the triangle side, the height of that from the top of the triangle straight down the side, the height of the triangle is 5.5. So that's the height of the triangle side, not the height of the overall pyramid. So use your calculator. 4 times 1/2 is 2. 2 times 3 is 6. 6 times 5.5, I think that's, isn't it 33? If you add those up, I think it's 42 square centimeters. So again, we had the bottom, which was 9 because it was a square, and the sides, 4 triangles, half times base of the triangle times height of the triangle. The height of the triangle is 5.5 for each of the 4 sides. There we go. Number 21, right circular cylinder topped with a hemisphere. Hemisphere just means this is a half of a sphere. Hemisphere means a half a sphere. So we have a right circular cylinder topped with a hemisphere, a half a sphere. So how do we go about doing this? Okay, so to find the surface area, we have 2 parts. So we have the part on the top. Well, we have the half sphere on the top. What's the formula for the surface area of a sphere? It's 4 pi r squared, but then we have to take a half times it. Does that make sense? It's half of a sphere. So half of the 4 pi r squared formula. And so we have the half sphere. That's the top. And then, right, because that'll be this top. And then we have, well, here, let's do that part first. So a half times 4 times pi. And what's the radius? The radius, remember, radius is always from the middle to the edge. So the radius must be 6, right? It's half of that 12 because you can tell that 12 is all the way across. So the radius must be 6. It's only half the way across. The radius is from the middle to the edge. So a half of 4 is 2 times pi. 6 squared is 36. 2 times 36, 72 pi. So we got the top. We got the half a sphere on the top. Next, let's do the sides. Actually, yeah, okay, let's do the sides. How do you do the sides? Now the sides, this right here, and the back, right? They're all the way around the sides, front and back, the whole sides. What's that going to be? Well, remember how we deal with this? This is a shape that, let me kind of erase all my scribbles here. If you cut it open, kind of like a label going around a soup can. Imagine that's a soup can. If you cut it open right there, and open it up, you're going to get a rectangle, aren't you? You're going to slice it open. It's going to be a rectangle if you cut it open. And the area of a rectangle is one side times the other. This is the 20 right here. This is 20 from... a little trouble here. From there to there has got to be 20. That's got to be 20. That's the height of the thing. Here, let me just stick it on the outside. It'd be better. So this is 20, because that's this 20 right here. That's the height of the rectangle. How wide is the rectangle? How far is it from here to here? What is that? Well, that's how far around the top edge of the circle is there, right? That's how far around, which is 2 pi r. And this is the height, which we know is 20. So the formula is 2 pi r h. Remember, that's the sides of a right circular cylinder, which is like a soda can or a soup can, either way, same thing. So, right, because all the way around this edge up here, this edge right up here, around this edge is 2 pi r. That's how far around the edge of a circle. You don't want to confuse that with the area of a circle. That's the bottom. On the bottom, we have the area of a circle, don't we? What's the bottom? The bottom is a circle, right? And what's the area of a circle? Pi r squared. That's different than 2 pi r. See, there's two different things going on here that you want to keep straight, because it's easily confused by a lot of students. The bottom is a circle, area of a circle. So that's the bottom. We have the top, which is a half a dome, half a sphere. The sides, which if you slice them open are a big rectangle. And the bottom, which is a circle, pi r squared. Now the hardest part, here I can finish, let me finish this. The radius, what was the radius again? The radius was from the middle to the edge. The radius is 6. Pi times 6 squared, that's 36 pi. So that's the bottom circle. This is the top half a dome, half a sphere. Now I got to finish the sides. The sides, remember, we cut it open, was a rectangle, and the formula is going to be 2 pi r h, because it's 2 pi r around the outer edge of a circle. So that's how far around the outer edge. A lot of people confuse the 2 pi r formula and the pi r squared formula, because they both have the same three pieces, a 2, a pi, and an r. It's just for the area, the r gets in the power zone, and when you're just talking about how far around the edge, not the area in the middle of the circle, then the 2 just goes in the front. Easy to remember because area is always square unit, so it makes sense the unit is squared for area. All right, let's finish up the sides here. 2 pi r, the radius is 6. The height, here's the height, it's the 20. That's the height of the sides. It's not the height of the overall thing, but it's the height of the sides. So 2 times 6 is 12, times 2 is 24 with a 0, 240 pi. Add these three up. This and this and this. Add those up because, we have all those surfaces to add up. We have the dome on the top, the half a sphere on the top, the sides, which is a rectangle if cut open, and the bottom, which is a circle. Add that up, and we get, 108, 348 pi, it looks like to me. 348 pi, and that's going to be feet squared because area is always square units. So if you wanted to paint that thing, the top, the sides, the bottom, the whole thing, you would need 348 pi square feet, foot by foot squares of paint to make that happen. So there we go. That was a hard one. And now here is another tricky one. How are we going to do this one? Well, we have, again, some different pieces. The top is, again, a half sphere. So we know how to handle a half sphere. We just did it. It's half of 4 pi r squared. That's half of the surface area of a whole sphere. So that's a half times 4 times pi. What's the radius? That's just the 12, isn't it? Because that goes from the middle to the edge. That's 12. So in the last problem, they gave us the 12 was all the way across. That was the diameter, right? Diameter goes all the way across. We had to cut it in half to get the radius of 6. This time they're just giving us the radius straight from the middle to the edge, 12. So half of 4 is 2 pi. 12 squared is 144. 2 times 144, 288 pi. So there's the top. That's the area of the half dome top, the hemisphere, the half a sphere top. Now we've got to do the sides of the cone. Right? That's a cone. Looks like a big ice cream cone. So that's the sides of the cone all the way around these sides, including the back. How do you find the area of that? Well, remember we had that formula earlier. It was pi r L. What's L? L is from there to there. It's the slant height. L is the slant height. It's not the actual height. It's the height along the slant of the cone part, just the cone part. So how are we going to figure out the L? First, we have to find L, and you can probably see how we're going to find L. We're going to do the Pythagorean Theorem, aren't we? Because we have a right triangle. Boom, boom, and then the L here is, the L's the C. It's the side across from the right angle. So 4 squared plus 12 squared is L squared. So we get 16 plus 144 is L squared. That's what? 160. is L squared. And so then we root it, and so L is going to be the square root of 160. We got to break that down. So that's 16 times 10. 16 is 4 times 4. 10 is 2 times 5. I'm not going to break down those 4s. Why? Because there's 2 of them. Remember, whenever you find 2 of something, that ships one of those to the front, because that's what square roots do. They're a 2-for-1 deal. So we end up with 4 in the front, right? See why I didn't break those 4s down to 2, 2, 2, 2? Because you don't need to. As soon as you see 2 of anything, ship 1 out. That's what square roots are, is a 2-for-1 deal. What's left on the inside? 2 times 5 is left on the inside, goes back to 10. L is 4 root 10. So all that work is to find L, which is 4 root 10. So now we can come back up here. The sides are pi RL. Pi, what's the radius? It was 12. And the L, 4 root 10. Kind of ran out of room there. Let me, whoops. Let me squeeze that in a little bit better. So pi RL is pi times R, which is 12 times L, which is 4 root 10. So bring it up here. 12 times 4, 4 times 12, 48 pi root 10. So you multiply the 4 and the 12 together to be 48, and then the pi and the root 10. So 48 pi root 10, and over here, 288 pi. They have to be added together. We have the top and we have the sides. There is no bottom on this one. The bottom is just a point. No surface area there. So the overall answer to this question, the total surface area, is 288 pi plus 48 pi root 10. Just add them up. And that's how they want us to leave it, just like that. There's really nothing more we can do. And we'll say square centimeters because area is always square units. And they want us to leave an exact answer, so we leave it just like that. We can't combine those together. We can't add those together because this one's a root 10 kind of term, and this one doesn't have a root 10. I don't know if you remember roots, but if one of them has a root and the other doesn't, they have to stay separate. They're unlike terms. We just leave it like that. There we go. Okay. Number 23. Changing gears here. Complete each of the following conversions. So we're back to conversions. Now it's 3-dimensional. Notice we've done 1-dimensional conversions, 2-dimensional conversions, and now 3-dimensional, third power conversions here. So how do we do that? Well, first off, the metric system. Remember, for the metric, it's all about just move the decimal, because the metric system is base 10 and our number system is base 10. So they fit hand in glove, and so they made the metric system go by tens, so you just need to move the decimal. They made it convenient. All right, so right in the middle goes meters, remember? Decimeters, centimeters, millimeters. Make sure you have this chart on your notes for the exam. Decameter, hectometer, kilometer. Okay, so where are we going here? We're going from cubic meters to cubic kilometers. So from meters back to kilometers, 1, 2, 3 jumps to the left. To go from meters back to kilometers. 3 left times 3 because of the third power. Right? You multiply, if it's third power, you multiply by 3. If it's second power, you multiply by 2. So because it's third power times 3 equals 9 decimal places to the left. That's a lot. So we need to move the decimal 9 places to the left. Because on the metric chart, from meters back to kilometers was 3 jumps left, times 3 because everything's third power. So 9 decimal places to the left. So let's go back to this number and where's the decimal right now? I don't see a decimal. So where's the decimal whenever you don't see it? It's at the end of the number. Go 9 to the left. 1, 2, 3, 4, 5, 6. I'm to the edge of the number. 7, 8, 9. Those are going to bring in 3 zeros. So it's going to be 0.0006 675. And you can throw a 0 in the front if you want to. It's optional. The zeros in the back, we don't need them. It's 0.000675. 9 decimal places to the left. And the first 6 got us to the edge of the 6. The last 3 brought in zeros. Now, it's a little harder on part B because part B is English units. And so, you know, for English units, we've got to use fractions, don't we? English units, it's all about fractions. So 200, bring it down here. Cubic inches, you put it over 1, make it look like a fraction. We're going to cubic yards. I'll put cubic yards over here. So remember how this works. Now we multiply. We put in the denominator what we want to cancel. Now don't make it cubic inches right away. Just normal inches. We'll cube it at the end. What can we go to easily? Remember the conversion? 12 inches is 1 foot, and 3 feet is 1 yard. Have those on your notes for the exam. So we can easily do this one. Right here, we can go 12 inches is 1 foot. So 12 inches, 1 foot. Now nothing's third power yet, but now we need to make it third power, don't we? So let's come in here and we'll go third power, third power, third power, third power. So you see how I third power every part of that fraction, the units and the numbers, all at once, all at the same time. Now cubic inches will cancel cubic inches, and we're in cubic feet right now. So we keep going. We need one more step. Times, you know the deal. We're going to put feet at the bottom here, and feet we can easily go to yards. 3 feet, 1 yard. And now we do what? Third power, third power, third power, third power. Right? We third power everything. Again, I showed you that earlier. I want to make sure you understand that. It's because let me draw it again real quick. I think it's worth our time. So this is 3 feet. So let's say each of these is a foot. This is 1 foot, 1 foot, 1 foot. And this is 1 foot, 1 foot, 1 foot. So then all together, this is 1 yard. And the width is also, because 3 feet is 1 yard. So this is 1 yard. So this is a square yard. This is 1 square yard because it's a yard by yard. It's 1 yard tall and 1 yard wide. It's 1 square yard. It's a square that's a yard by a yard. And how many square feet is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you see it's 9 square feet, meaning it's 3 squared square feet? Do you see how you take the conversion? The normal conversion is 1 yard is 3 feet. 1 yard is 3 feet. And then if you just, this is square. Yeah, I'm sorry. So that's true. I mean, what I'm saying is true. But this is actually 3-dimensional. So if we wanted to make this 3-dimensional, this problem got a lot harder. And this is all. You don't have to do this, but I just wanted you to see this is true. So I'm going to try it. Here we go. There. Now that's a cubic yard. So that's 1 yard by 1 yard by 1 yard tall. Wait, I already had the tall. I need deep, huh? So it's a yard tall. Let's put the yard over here. It's 1 yard tall, 1 yard across, and 1 yard deep. It's a yard by yard by yard. That's 1 cubic yard. Does that make sense? That's 1 cubic yard. Well, how many cubic feet are in there? Well, remember there's 3 feet in every yard. So if it's a yard tall, that's 3 feet tall. If it's a yard wide, that's 3 feet wide. And then, can you picture it? My limited drawing skills here. That's going to be 1 foot, 1 yard deep is 3 feet deep. So it's a big old Rubik's Cube, isn't it? Right? There's 9. It's 1 yard deep here. There's 9 in this layer. That's a 9 in this layer, 9 in this layer, and 9 in this layer. Right? This is 1 yard deep, 1 yard tall, 1 yard wide, 1 yard deep, 1 cubic yard. Has 9 square feet in the first layer, 9 in the next, 9 in the next. So it's got 27 cubic feet. In other words, 3 cubed cubic feet. I just want to prove to you that this is true. 1 cubic yard is 3 to the third, 27 cubic feet. You can see it. This right here is 1 cubic yard, and in it is 27 little cubes that are each foot by foot by foot. Right? Each one of these little cubes, like this corner up here, this little cube up here, this little corner, is 1 foot by 1 foot by 1 foot. So it's 1 cubic foot. And there's 27 of those. So that's why it's true. All right, let's go back to the problem and finish it up. Let me put this back the way it was. So that's, you don't have to do all that. I just want you to see it's true. That you put feet down here first off. You put yards up here. You go 1 yard is 3 feet, and then you third power everything. And that's true. This is 27, isn't it? 3 times 3 times 3 is 27 cubic feet are really in 1 cubic yard. We're doing what's true. All right, we cancel out cubic feet. What are we left with? Cubic yards. That's what we want. Let's get our answer. What do we do on our calculator after all this work? Well, we're going to have to make it a big fraction here. So what's on the top? 200. What's on the bottom? 12 to the third times 3 to the third. That's a whopping number. I'm going to use my calculator. I'm going to go 12 to the third power times 27, 3 to the third power. I'm getting 46,656. We're going to reduce it. We're not done yet. But that's just 12 to the third times 3 to the third. So I multiplied the two numbers on the bottom. I've got the 200 from the top times 1 times 1. 1 to the third is just 1. That doesn't do anything. And then we're going to reduce it. Now, how do you reduce it? Well, you just start dividing by things. Like, I would right away say, I don't know, maybe 4. Divide top and bottom by 4. See if that works. See if they both go into 4. I bet they do. This will be 50 on the top, and take the bottom by 4. And I get 11, 6, 6, 4. Can we reduce it again? Will it go further? Yeah, well, you know the top and bottom are both divisible by 2 because they're both even, right? So that'd be 25 over, and then the bottom divided by 2 is 5832. 5832. That's as far as we can go. How do we know? Well, the top is no longer divisible by 2. 25 can't be divided by 2. We cannot reduce that fraction any further. 25 over 5832, and that's, what are the units on that? Cubic yards. So we reduce that fraction in the end. There we go. All right, number 24. We've got this ice cream cone again. Now you might think, well, didn't we do this one? Didn't we already do an ice cream cone? Yeah, we did, but this time, volume. If you look back, here, let me find the other ice cream cone. There it is, it wasn't far. Surface area. So just 2 problems ago, we just did the ice cream cone, but we found surface area. We found, like, if you had an advertisement that was a big 3-dimensional ice cream cone, you wanted to paint the outside or wanted material to go around the outside, how much surface area, how much area on the surface, we just figured that out back on number 22. Now we want volume, meaning we're going to fill up the inside, fill up the whole inside of that ice cream cone. How much ice cream is in there? Yeah, if you're ordering an ice cream, that's what you'd care about, is how much ice cream is in there. What's the volume of that thing? So how are we going to figure out volume? Well, we have a different formula. So first off, we have the top, the half of a sphere that is on the top. We have a volume formula for a half a sphere. What's that? Now careful, it's not the same as the other one. So we're going to take half of 4/3 pi r cubed. So that's not 4 pi r squared. That's the formula for surface area. of a sphere, right? 4 pi r squared. The volume of a sphere is 4/3 pi r cubed. Similar, a little different. Third power on r and divided by 3 in the front there, 4/3. Little bit different formula. So we're taking half of that. And so let's work that out. It's going to be half of 4/3 pi. And what's the radius? The radius is that 4, isn't it? Because that's from the middle to the edge, which is radius. Here, 2 goes into 4 2 times. We can cross-cancel fractions, remember. So what do we have then? We have 2/3 times pi, and 4 to the 3rd power, if you use your calculator. 4 times 4 times 4, what is that, 66? I think it's 64. Yeah. Okay, and now what do we do with that? Well, this 64 is over 1, right? Anytime a whole number is interacting with a fraction, put it over 1. Multiply the top, 2 times 64, 128 pi. The pi is over 1 also. Pi goes in the top, over 3. So that's just for the half sphere on the top. 128 pi over 3. Now, let me get rid of this. Okay, so that's the volume of the half a sphere on the top. Now we're going to go for the volume of the cone. Now, what's the volume of the cone? Well, volume formulas are actually easier than surface area formulas. Volume formulas are pretty straight ahead. If you have, the volume formulas are basically the base times the height. So for the cone, the base, what is the base? It's a circle. So that's pi r squared times the height of the cone. But when they come to a point, like a pyramid or a cone, you put a 1/3 in the front. So that's how volume formulas work. 1/3 pi r squared h. So have that formula on your notes for the exam, 1/3 pi r squared h. So let's use that. 1/3 pi, let me separate these here. We're going to add them in a minute. And what's the radius? Again, it's the 4, isn't it? Times the height. Now the height is the 11. Now you might think, well, that's not the height of the whole shape. No, but it's the height of the cone. And I'm doing the cone right now. Right? That's from the tip top of the cone to the bottom of the cone, straight down at 90 degrees. That's always how height works. So the height is 11. So what do we get? So the pi and the 4 squared is 16 times 11. I'm just going to multiply my calculator. 4 squared, 16 times 11. What's that? 176 over 3. The 3 goes to the bottom, doesn't it? Because these other guys are over 1. They go to the top. The 3 goes to the bottom. So now we have the surface area for the half sphere on the top. We have, the volume of the half sphere on the top and the volume of the cone base. Add those together to get total volume inside the half dome top and the cone base. If you add 128 pi and 176 pi, they already have a common denominator. So just add them up. And I'm getting 304 pi over 3. And that's our answer, cubic centimeters. Notice it's cubic now because that's volume. Volume is 3-dimensional, isn't it? It's not just on the surface, the flat 2-dimensional surface. It's 3-dimensional. We're filling up the inside, the volume, 3-dimensional. There we go. All right, number 25. We're trying to find the volume of this right triangular prism. So I want the volume of this thing. We want to fill up the inside. Notice we've changed gears from surface area problems now to volume problems. You got to keep that straight when you're taking this exam. You got to always be asking yourself, is this a surface area question? Is it just what's on the surface? Or is it volume? Are we filling up the inside in the volume? Okay, so volume of a prism, any kind of prism. What is a prism? Let's make sure we're clear on a prism. Prism has the same two shapes. Has two shapes the same, I should say it that way. So a prism has two shapes that are the same. Two shapes that are the same. So prism has two shapes that are the same. So, okay, two shapes that are the same. And we call those the bases, usually the base. Yeah, we call those the bases. Now this one, well, so looking at this three-dimensional shape, looks like a tent, doesn't it? What two shapes does it have the same? Well, triangles. It has this triangle, and it has that triangle. Now I think, well, what about the rectangles? Doesn't it have rectangles? It does, but it doesn't have two rectangles. It has three. So those are not the bases, right? You might, right? Look at this rectangle right here. Here's the right side's a rectangle, the left side's a rectangle, and the bottom is a rectangle. It has three rectangles. So those are not the bases. So again, one more time, let me be really clear with you about what a prism is. A prism is something that has two shapes the same, and we call those the bases. So whenever you look at a prism, you want to ask yourself, what are there two of? Well, there's two triangles. There's two triangles. So those are the bases. Now they can turn this. On the exam, I could stand this tent up on the triangle, put the triangle on the ground, you know, and the other triangle up in the air. So they can move them all around. You've got to be clear what the two bases are, however they have the prism sitting. So how do you do volume then? Well, the volume of a prism is just going to equal the base area. So I'll just write base area times height. And the height is how far between the bases. So the height is how far between the bases. So in this case, that's the 16. That's the height. That's how far between the two triangle bases. Does that make sense? Area of the base times the height. Right? You could let me make sense of that. I want these to make sense for you. Imagine that I said, "Hey, there's this weird new building. They're oh, I didn't do that very well. They're building a new strange building on campus, a new office building for the faculty." And they're going to make it a triangle on the ground, a triangle on the top, and it's going to be the same all the way up. And there's going to be 10 floors, 10 offices on the bottom floor, 10 offices on every floor, and it's 3 stories tall. That's the height, right? The height is 3 stories tall. It's a 3-story tall building, and it's triangle on the ground, triangle on the top, straight up, and same thing all the way up. 10 offices on the ground floor, 10 offices on the second floor, right? 10 offices here, 10 offices here, and 10 offices there. How many total offices? 30, right? 3 times 10. Look at what you're doing. You know that this is the base. The 10 is the base. How many offices on the ground? The base. And the 3 is the height, isn't it? Do you see how it's just the height times the base? This is the base times the height. Same thing. So whenever a shape has 2 of the same thing, like triangle on the ground, triangle on the top, you just take the ground floor, whatever's on the base, times the height when it goes straight up. And for a pyramid, let me go ahead and do the pyramid right now. If you have a pyramid, then you might have a triangle and it comes up to a point. Instead of coming straight up, it comes to a point. It's the same formula with one small difference. So base area times height, and you throw a 1/3 in the front. Because you lose a lot of the volume. You only have 1/3 of the volume when you come up to a point. And that's the same thing for a cone. It's 1/3 times the base times the height. Because a cone like this, right? Base, whoops, I didn't draw that very well. Cone is a circle, comes up to a point. So cone, it's the same thing. It's 1/3 the base times the height. And the base, what's the base of a cone? What's on the ground floor over here of a cone? A circle. So it's 1/3 pi r squared h. So notice both the shapes that come to a point, a pyramid or a cone, for their volume, this is volume again, these are all volume. We've changed from volume to surface area now. So whenever you're doing volume of any shape that comes up to a point, like a prism, like a pyramid or a cone, you end up with this 1/3 in the front because it's it loses a lot of volume. It's only 1/3 what it used to be because it comes to a point, instead of coming straight up, it loses a bunch of volume. Whereas if it's a prism, if it comes straight up, it's just area of the base, straight up the height. No 1/3 at all in the front. All right, so let's use that now. That's all the deep theory there behind all these volume formulas. Let's now calculate the volume of this particular prism. So again, it's going to be the base area times the height. And so what's the base area? So the base is what there's two of, remember? So this is the base right here. This is the base. And this is the base. These are the bases, right? It's what there's two of. With a prism, there's always two of something because the bottom and the top, or if they turn it sideways, the right and the left, are the same two shapes, and it's straight in between. So the bases are triangles. What's the area of a triangle? Half base times height. Half times 6 is the base of that triangle, and the other 6 is the height of that triangle, times, now the height, this is the height between the bases. You got to be careful. There's two different heights we're talking about here. Here's the height of just the little triangle. That's a half times 6 times 6 is the area of that triangle because it's a half, the base of the little triangle, the height of the little triangle. But then the other height is the height between the two bases. That's 16. So let's work that out. Half of 6 is 3. 3 times 6 is 18 times 16. I don't know, use your calculator. I'm going to use mine. 288, it's looking like. 288, and what are the units there? Cubic centimeters, because volume is always cubic units. There we go. So it's whenever a prism is any shape that has two of something that match. Same shape to same shape, base and height. So the bases are triangles. It's base times height. Whereas the height is the height between the bases. So the base is a triangle, half base times height for that triangle, times the height between the bases. Comes out 288. There we go. All right, now here's the cone. We just went over the formula for the volume. Again, we're filling up the inside of that cone. We're not just talking about the surface area. So the volume of a cone, you want to have this formula on your notes for the exam. Remember, any shape that comes to a point, like a pyramid or a cone, it's 1/3 area of the base. 1/3 area of the base times the height. So that's 1/3. What's the area of the base? What is on the ground floor there? What is the base? Circle. So it's 1/3 pi r squared h. That's the actual formula right there. I'm just giving you the reason why. So the volume then equals 1/3 pi, and because pi r squared is the base. The base is a circle. So what's the r? The r right there is the 5, isn't it? And the height? The height is the 12. So multiply that in your calculator. I think you're going to get 100 pi. And what are the units on that? Cubic centimeters, because volume is always cubic units. There we go. 27, volume of a sphere. Well, there's just really a special formula here. This is volume for thirds pi r cubed. That's different than the surface area formula. That's the volume formula for a cube. So let's crank that out. That's going to be 4/3 times pi. What's the radius? The radius is the 11. So again, be careful. What if I gave you on the exam, you could have something all the way across as 22. Then you would cut that in half to find the radius is only 11. The radius is from the middle to the edge. So 11 to the 3rd power. So I'll bring that down here. So that's 4/3 times pi. And then 11 to the 3rd power. I have no idea. I'm going to use my calculator here. 11 to the 3rd power. I'm getting 1331. Put it over 1. So multiply 4 times 1331 on your calculator. I'm getting 5324 over 3. The pi, you can put it in the top or the front. It doesn't matter because the pi is over 1. It's really in the top, or you could stick it in the front. It's the same thing either way. 5324 pi over 3. That's not, you can try dividing by 3, but that number comes out. If you divide by 3, you get a decimal. They don't want a decimal. They want a fraction. So there's our answer. And we have to give the units cubic centimeters because, again, volume is cubic units. There we go. 28. Okay, so this is a combo shape. We have a half a sphere on the top. So let's do it. So half a sphere on the top. So how do we find that? Well, it's going to be half. And what's the volume of a sphere? 4/3 pi r cubed. So let's work that out. It's a half. We'll start with the top here. 4/3 times pi. And what's the radius? What is the radius? The radius is from the middle to the edge. Well, you see how the 40 is going all the way across, so the radius must be 20. So 20 to the 3rd power. Let's cross cancel. 2 goes into 4 2 times. So we get 2/3 pi, and then 20 to the 3rd power is a big number, 8,000. Put that over 1, put the pi over 1. 2 times 8 is 16,000 pi over 3 on the bottom, right? Because it's 3 times 1 times 1 is just 3 on the bottom. So there's the volume for the top part, the half a sphere on the top. Now we have to do the volume for the sides. Or not the sides, sorry, the base. What's the base? It's a soda can. They call that a right circular cylinder. So this shape here in the front, we're filling this up. Right? I want the volume of that right circular cylinder. What is it? Well, it's the ground floor, which is the base, times the height, right? Because you're filling it straight up, just like that office building example I gave a couple problems ago. So the volume is going to be ground for the base area. It's going to be base area times the height. And what's the base area? What is the base? It's a circle. Pi r squared times the height. There's the formula for the volume of a right circular cylinder, a soda can or soup can kind of shape. So it's pi, the radius, again, is 20, right? Times the height. Let me get back to this a little better. What is the height? The height is the 70. It's the height of the soda can part. And so that's going to be, I don't know, let me see, for 28 and then 3 zeros, 28,000 pi. 28,000 pi. So now we need to add those together. If we're going to add 28,000 pi to this, we're going to have to get a common denominator, aren't we? The only way to add those two together is with a common denominator. So this is over 1, because we have to add. We have the the base, the right circular cylinder, the soda can base, and we have the half sphere on the top. We have to have the volume for each piece. We have to add them together to get the total volume for the whole shape. So multiply top and bottom of this fraction by 3. You get, what's that, 60, 24, 84,000 pi over 3. Right? I just multiplied top and bottom by 3. So in other words, if you divided this, if you took 84,000 divided by 3, it'd go right back to 28,000. It's the same thing. It's just a fancy way of writing 28,000. Why? Because now I can add these guys together because they have a common denominator, right? The only way to add two fractions is to make their bottoms the same. So I multiplied top and bottom by 3 to make it have a 3 denominator, so it can add to the other one that has a 3 denominator. Add them up on your calculator. When you're going to get 100,000 pi over 3. 100,000 pi over 3. And the units? Cubic centimeters, because again, it's volume. There we go. 29. Find the volume. You got a pyramid. So we talked a couple problems ago about how you find the volume of a shape that comes to a point. Remember, it's the 1/3. Any shape that comes to a point, like a pyramid or a cone, you only got 1/3 of the volume. You lose a bunch of volume. 1/3 times the base area times the height. And so, what's the base area? In this case, it's a square. 8 by 8 square. So 8 times 8. And what's the height? Well, that's this 8 right here. That's the height of the pyramid, isn't it? That goes from the tip top straight. And see why they have that going straight down with that right angle at 90 degrees? Because that means that's the height. Right? If you measure your height, you have to go straight down to the ground. So that's the height of the pyramid. So it's 1/3 times 8 times 8 times 8. That's kind of nice. What's that going to be? So 5, these are all over 1. 512 over 3. And you can divide that in your calculator, it'll just be a decimal. They don't want a decimal, they want a fraction. So we'll just leave it, and it's cubic centimeters because volume is always cubic units. So the area of the base was 8 by 8, the height was 8, and you always have a 1/3 in the front for volume when you come to a point, like a pyramid or cone. Number 30. We want the volume of that kind of house, a little house shape. So how do we find the volume of that shape? Well, we have the triangular prism top. So if you look at this thing up here, this is a triangular prism. That's the top. It's a triangular prism. So we need to find the volume of that first. So how do we find the volume of that piece? Well, remember we did volume earlier for a prism. For a prism, it's always base area times the height And when we say height, we mean the height between the bases. So what's the base? And you might think, well, what's the base? Is the base is what there's two of. So in a triangle is what appears twice. So what shape appears twice? Triangle. Triangle in the front, you could picture back here, must be another triangle. If you could see that back there. Triangle in the front, triangle in the back. Let me draw this a little better. Triangle in the front, triangle in the back. So that's what there's two of. Not rectangles. Do you see what I mean by not being rectangles? Because that's the other thing that might confuse people. They might think, oh, no, there's this rectangle down here. If you draw on this back part again, and keep messing this up. Try this a little better. There we go. People might say, well, no, there's a rectangle down here. This rectangle is the base. That's the bottom of it. Careful. Base does not always mean bottom when it comes to prisms, because they can turn the prism, they can flip it up or down or move it all around. So we can't just say what's currently on the bottom. No, that won't work. It's not, rectangle is not the base. Well, why not? Because there's not two rectangles, there's three. There's a rectangle on the ground, and then there's two rectangles on the right and the left. The base is always what appears twice. So that's super important that you understand that. For a prism, the base is what there's two of. And what are there two of? Triangle here, triangle there. There's two triangles. That's the base. This thing's just sitting on its side. But there's two triangles. The triangles are the bases. So, what's the area of a triangle? You know the area of a triangle. Half base times height. For the base and the height of that triangle. Well, what's the base and the height of that triangle? Well, this 40 right here is the base, and the 7 is the height, huh? So it's kind of running out of room here. Let me move this up. It's a half times base times height. It's a half times 40 times 7. And now times, so that's the base, and now the height between the bases. So again, we have this invisible triangle over there. Now I made it too big. So there we go. So, and I missed, going too quick. So the between them, this right here, this 43, that's the height between the bases. That's the height between, that's the length, we call it the height between the bases, between what there's two of. And so that's the 43. So again, the base of a prism is what, the bases of a prism is what appears twice. What appears twice. That's the base of a prism. So the base is the triangles. All right, so use your calculator. Multiply this out. I'm going to do it too. Let me see. Now I'm getting 60, 20. So that's just the top part. Now, that's the hard part though. So 60, 20 is the area of the, the roof, the volume, I should say not area, the volume of the roof. So now we have the base, which is it's a big rectangle kind of thing, big box, the box on the base. And so we mean all of this shape. So what's the volume of that shape? Well, that's just going to be length times width times height, isn't it? Because again, it's really a prism. It's another prism. This one's just a rectangular prism. Why? Why is it a rectangular prism? Because it's got two rectangles. Do you see that? It's got a rectangle in the front right here. And then in the very back, if you drew in this back here, it'd have a rectangle back here. And then, so 43 is the distance between them. So it's length times width. That's the rectangle in the front. So that's going to be 13, if you can still see that here. I've scribbled so much on this thing. It's 13 by 40, because that's the base on the front times the height between the bases, 43. You multiply those all together, length times width times height. Because it's really, length and width are the base times the height. All right, so 13 times 40 times 43. I'm getting 22,360. Now hold on. I want to make sure this is clear. You might be saying, "Man, mister, that's not the base. I'm confused." Let me make sure it's clear. What if we drew in this back part back here? If I can do it. Oops, not very good. Come on. Like that. Oops, I should have met about right there. No, it doesn't look very good, does it? Oh, no, that's not right, is it? I am really messing this up, so this should have come over like this. All right, I'm getting a little better here. There we go. Draw that part in the back there. Right, so you might say, okay, there's the shape. So the base is, the base here is this. You could use that as a base. That's fine, and this will be the top because there's two of those rectangles. And so that's the base, area of the base, times the height between the bases, right? That's how we do a prism. It's a big prism. A prism is anything that comes straight up with two shapes. And so there's a 40 by 43 is the area of the base, right? It's a big rectangle, times the height between the bases. The height is 13. So see, in the end, you just end up multiplying those same three numbers. I just did it in a different order. It doesn't really matter. Multiply those three together. You'll get 22,360. Final step, add the volume in the base with the volume in the roof area. Add those up on your calculator. That's what I'm doing right now. And I'm getting 28,380. 28,380, and what's the units on that? Cubic feet, because it's volume, which is always cubic units. So there's the last volume problem. All right, so on 31 now, we are considering the translation. xy goes to x plus 2, y minus 4. So translation is a movement. We're basically going to take this, what is that, a parallelogram? Going to take that parallelogram and we're going to move it. How are we going to move it? Well, x is going to go right 2 and y is going to go down 4. So we're going to do that with every dot. So let's take A and go right 2, down 1, 2, 3, 4. There we go. There's the new A. We'll call that A prime. And then we're going to do the same thing with B. Right 2, 1, 2. 2 jumps to the right, 1, 2, 3, 4 jumps down. There's the new B prime. Let's do the same thing with C. Go right 2 jumps, 1, 2, down 4 jumps, 1, 2, 3, 4 jumps. There's the new C prime, and let's do the same thing with D prime. It's going to go 1, 2 to the right, 1, 2, 3, 4 down. There's D prime, so I didn't make that very nicely. And then connect up those 4 dots. There's the new shape. We moved the whole shape right 2 down 4 because that's what they said here. X is 2 to the right and y is 4 down. The xy becomes x 2 to the right and y 4 down. So what are A's new coordinates, A prime? So the coordinates right there for A prime, what is that from the origin? That's what? Back 2, down 1, isn't it? Back 2, down 1. Coordinates are always from the origin. Back 2, down 1 for that one. What about B? Where's B from the origin? Right 1, down 1. Right 1, down 1 from the origin. What about C prime here from the origin? It's left 1, down 1, 2, 3, 4. Left 1, down 4 for C prime. Finally, D prime from the origin. D prime is right 1, 2, down 1, 2, 3, 4. Right 2, down 4. There's the coordinates of all the new shapes, and which one of these is the right image shape on that? Can you see it's right here? That's the correct image of that one. So there we go. Just moving the whole parallelogram right 2, down 4, finding the new coordinates for each of the 4 points having been moved right 2, down 4. Number 32, we're talking about now we're getting to rotations, 180-degree rotation. Well, the easiest way to handle rotations is to start from the origin and move to the point. Now, go sideways first. You don't have to do it this way, but I think this will be easiest. Go sideways first, and then up and down, kind of like an arm reaching out, connecting from the origin out to the point K. And now we're going to rotate this arm 180 degrees. Remember, 360 is all the way around, so 180 is halfway around. So here's what I suggest. Just forget about this second part and just rotate the main part of the arm 180 degrees. That's halfway around, right? So the main part went left 3, so the new arm will go right 3 at first. You good so far? That's 180-degree rotation. Doesn't matter if I go top or I go bottom. 180 degrees either way is halfway around. It doesn't matter which way you go. If you turn halfway around, it doesn't matter which way you do it. You end up pointing the exact opposite direction. Okay? So before, the arm was 3 to the left. Now the arm goes 3 to the right. And then it went down. It went 3 this way and then down 4 jumps, right? 1, 2, 3 jumps this way and 1, 2, 3, 4 jumps that way. So when you rotate, now that arm's going to be rigid. The arm does not bend. As we rotate it about this center here, as we rotate the arm, it's not going to move. So it's going to be rigid as we rotate it. So about this center right here, I'm going to rotate it. So it's going to, can you picture where it's going to go? It's going to go right 1, 2, 3. And now it's going to go up, isn't it? Right to there, up 1, 2, 3, 4. So when you rotate the arm 180 degrees, now it's going there. So there is K prime, the image of the original point K. And they want the coordinates, don't they? So what are the coordinates of that point? Coordinates are always from the origin. It's 1, 2, 3 to the right, and 1, 2, 3, 4 up. So 3 to the right and 4 up. There is where the new point, K prime, ends up after rotating 180 degrees. So that's what we mean by 180-degree rotation about the center. Where does K move to? Let's try the next one. This time we're taking the whole triangle and doing a 90-degree counterclockwise rotation. So let's do them one at a time. We'll just go alphabetical order, start with J. So from the origin to J. Remember, always do your arms straight over and then up or down, but don't worry about the up or down part. Just do the straight over first. And now rotate that. How are we going to rotate that? 90 degrees. Not 180 this time, but only 90. Counterclockwise. Now, which way does a clock go? Clock hand goes that way, doesn't it? I didn't draw my clock so well. So that's clockwise. Clockwise is that direction. So this is counter. It's the opposite. So it's going to go, so this direction then is counter clockwise, isn't it? So it's going to go up 90 degrees. So the old arm went over 1 and then it went, let's try to be clear here. The old arm went over 1, up 1 to get to the point J. So the new arm is going to go up 1, over 1. Can you see when that, because it's rigid, we don't bend it, we just twist it. About that center right here, we just twist it 90 degrees. So instead of going right 1, up 1, it's now going to go up and left. And so there's going to be the new point J prime, the new coordinates for J. So I'll just put them over here because there's no room there. So the new J, whoops, make my J a little bit better. The new J, what's the coordinates of that point from the origin? So from the origin here, it's back 1, up 1, back 1, up 1, to get to the new point right there. Back 1, up 1. That's the coordinates of the new point J. Now let's do the same thing for K. Here's K. So how do we get out to K from the origin? we go straight over, and let's don't do the other part yet, just start with that part of the arm, go straight over, well you can do the whole thing, straight over and straight down, and we're going to rotate it 90 degrees counterclockwise, this direction, so 90 degrees, so the new arm will go, instead of over 4, it'll go up 4, won't it? See, the other one went over 4, so go up 4, and then can you picture it'll go to the right, so this is 1, 2, 3, 4, and then 1, 2, 3, 4. 4 and 4. So it'll go up 1, 2, 3, 4, and then right 1, 2, 3, 4, right there. Oops. Can you picture that when we rotate that? It'll go over 4. So this will be the new K prime right there. There's the new K prime. It's the new K. What's the coordinates of that from the origin? From the origin, from right here, it's right 1, 2, 3, 4, up 1, 2, 3, 4. It's over 4, up 4, isn't it? 4, 4. Now, finally, so that's the new K. I'll just leave that right there. It's the K prime. And we also had the new J, which is there. That's the J prime. Okay, last point. We're going to do the new L. So there's the L. So how do you get to the L? Starting from the origin, you go over 4, up 3. And then you're going to rotate that 90 degrees counterclockwise. Let me get that out of the way again. Now, so the other arm was over 4, up 3, over 4, up 3. The new arm will go, so 4 in this, just concentrate on this part here. 4 will become up 4 now, won't it? And then this arm will go 3 that way. Boom. So now it's up 4, over 3, isn't it? There it is. That's going to be the new, right here. This is going to be the new K. K prime. What's the coordinates of that one from the origin? Back 1, 2, 3, up 1, 2, 3, 4. Back 3, up 4 from the origin. So that's the new, or I mean, did I say K? Sorry, that's the new L. That's the new L. The new L is back 3, up 4. That's the new L. So we have it. You could put them all together now. Connect up the new triangle. So the new J was right there. It's the J prime, the L prime, the K prime. And then connect the 3 of them together. There's the new triangle after we rotated counterclockwise 90 degrees about the origin. So we rotated about the origin 90 degrees counterclockwise, and the whole triangle moved like that. Okay, let's go to 34. Now we're going to reflect across lines. So we're going to reflect across the line y is negative 2. So the first thing we've got to do is get the line y equals negative 2 on our graph. So that's the line that hits the y-axis at negative 2. That's this point right here, right? So boom. There's the line that's the line y equals negative 2. It goes through the y-axis at negative 2. Okay. So now, let me get rid of that. So now I'm going to reflect the points across that line. So every point is going to reflect right straight across that line, same distance to the other side. Let's start with F. Well, let's go alphabetical. We'll start with D. So the D point here is going to go 1, 2. Remember, they always go straight at the line and then same distance other side. That's how mirror images are, right? When you're looking in a mirror, you see your image and it looks like it's inside the mirror, beyond the mirror, same distance to the other side. So if it's 2 this way, it's 2 that way. So here is the new point D prime. So the new D, what's the coordinates of that? That's over 2 up 0. That's where the new D is going to be. Now what about E? Here's E way back here. It's going to go straight at the mirror. 1, 2, 3, 4, 5. And then so 5 to the other side. 1, 2, 3, 4, 5. There's the D prime. Or I'm sorry, that's the E prime. So that's the new point E. What's the coordinates of that point from the origin? Over 2 up 3, isn't it? Finally, we have the F. Going alphabetical here. So it's 1, 2, 3 to the line, 1, 2, 3 to the other side. Right there. What's the coordinates of that point? Looks like over 5 up 1. Over 5 up 1. So we could connect those 3 together. Oops, I forgot to label that last one. This is the new F prime. There we go. All right, so let's label them. Boom, boom, boom. There it is. We reflected that triangle. It looks like it does. It looks like a mirror image across that line y equals -2. We reflected it right over there. Okay, and we got all the coordinates, right? You have all 3, good. And now number 35, we're going to reflect, again, another triangle, this time across the line y equals x. So what's the line y equals x? Remember, that's the diagonal line that goes right through the diagonals of all those squares. That's the line y equals x. Why is that the line y equals x? Because all the points, see how 1 and 1, and this point 2 and 2, that's the point 2, 2, 1, 1, this is the point 3, 3, etc. Those are all the points on that line. The y value equals the x value. That's the line that has all the points where x and y are equal values. Okay, so you don't need to put those dots in there. I'm just proving that that is the line y equals x. Now, let's do our reflection. Let's start with L. How does reflection work? Remember, you go straight at the line, straight at it, 90 degrees. So not like this. You might say, well, there it is. That's straight to the line. No, that's not a 90-degree angle. This is not a 90-degree angle. That's not straight at the line, is it? Oh, okay, you mean like this. That's straight at the line. Nope, that's not 90 degrees. This isn't 90 degrees. That's not straight at the line either. What's straight at the line? Well, you got to move in the exact opposite direction that the line is. So I've got to go diagonal this way. You see, that's 90 degrees, isn't it? That's straight at the line. So you got to use the other diagonal direction, because that's the opposite direction, which means it's straight at the line. So anyway, how far is it? It's 1 diagonal jump and then a half. It's 1.5 diagonal jump. So you got to do the same distance to the other side. So half and 1. There it is. 1.5 to the other side. There's our new point L prime. So reflections always go straight at the reflection line, same distance to the other side. There's L prime. What's his coordinates? You can tell he's back 1 up 2, isn't he? Back 1 up 2. Now let's do M. Here's M. He's going to go straight at, so the other diagonal, 1, 2.5, 2.5, same distance other side, half, 1, 2. There it is. Did 2.5 to the other side. So there's the new M prime. What's his coordinates? Back 4, up 1, like that. And finally, we have N. So let's do N. It's going to go, now it's a little tricky here. You got to go diagonal. So 1, 2, 3, 4. It was exactly 4 diagonal box jumps to the line. So 4 to the other side. 1, 2, 3, 4. Right there. N prime. What's the coordinates? Looks like back 3 up 5. Back 3 up 5, the coordinates of that one. And then you just connect these 3 up. There's the triangle, mirror image reflected across the line y equals x. Looks like it, doesn't it? Looks like a mirror image reflection of the triangle So we just mapped out a reflection across the diagonal line y equals x. Number 36. So we're doing a dilation. So it's talking about a dilation. That means a dilation is a size transformation. Dilation means size transformation. Okay, so anyway, find the scale factor and the length of the designated side. So the scale factor, what is scale factor? Okay, so scale factor, it's always the image over the original. So scale factor is always image over original. So you want to have that in your notes for the exam. So what's the image here? Image of the segment of length 12 in bold. So here's the original, and the image is in bold, so this is the image. Right? You see that? This is the original. Right? They're saying the image of the segment of length 12, the image of him is in bold. So this is the image in bold right there. See, it's bold. So that X is bold, that's the image, and the original is the 12. So the image then is going to be the X over the 12, but that's no good. I don't know what X is, so I'm going to have to go down here and first find X, and then I'll come back up and find the scale factor. So how am I going to find X? Well, you know from earlier chapters that these two triangles are similar. These are similar. Let me write that here. Similar triangles. So with similar triangles, we know the sides have equal ratios. Right? With similar triangles, the sides have equal ratios. So I can use that to find things. Now, how are we going to do it? Well, you can take the x over the 12, right? The x over the 12, and say that's equal to the 10 over the 5. Now, that's wrong, but that's a very common mistake. I want to help with that and show you why that's not true. A lot of people do that, and they make a mistake right here. They go, well, that matches up. You know, the right side is to the right side as the bottom is to the bottom. Right? Right side is to right side. X is to 12 is 10 is to 5. No, the problem is 10 is not the bottom of a whole triangle. It's only part of the bottom. So here's how you do it correctly. That's not correct. How do we do it correctly? Well, I think it'll really help you to just draw the two triangles. Here's the little one. This is 12, 5, and 13. And then here's the big one all the way drawn out separately, where this is x, and this is what? This is going to be 5 plus 10, 15. The whole bottom is 15 there, isn't it? And then this part up here, 13 plus y. So that's what I would suggest. So those are your two similar triangles. Those two, why are those two triangles similar, by the way? Because they have two angles. Remember from earlier? This will be on the final exam, so it's a good review. See, they both have a 90-degree angle, and they both have this angle the same, because that's the very same angle in both of them. So they have two angles the same, so therefore they have to have all three angles the same, right? When you have two angles the same and the total is 180 for any triangle, the third angle has to be the same as well. So they have the same three angles. Remember, angle, 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 that proves the two triangles are similar. Meaning the big one is just a big version of the small one. They're the exact same shape. One's just a blown up or shrunk down version of the other. Same shape, different sizes, similar triangles. So when we have similar triangles, we can say their sides are equal. So not 10 over 15, right? X is to 12, right side is to right side, as bottom is to bottom. 15 is to 5. There we go. That's the correct ratio. Do you see that? Right side is to right side, x is to 12, as bottom is to bottom. So you can't use that 10. It's not the bottom of any triangle. It's part of the bottom, but it's not the whole bottom of any triangle. So you got to be careful. We got to use the bottom of a whole triangle. So how do we solve that little thing for x there? We go diagonal, diagonal, cross multiply. 5 times x is 12 times 15. 5x is, what was that, 180. Last step to get x alone, divide by 5. And x equals, is that 36? X is 36. So we found x, and that means we can also come back up here, plug it in right there, get 36 over 12, 3. So the scale factor is 3, meaning that the image triangle, this triangle, is 3 times as big as that triangle. And that makes sense, doesn't it? Because the bottom is 5 here, the bottom is 15 there. So the image is 3 times as big. This is 12. This x is 3 times as big, 36, like we just found it out. The triangle on the bottom is 3 times as big. The image is 3 times as big as the original. Finally, we're going to find y. How do we find y? Well, we can use the y right here. Boom, boom. So we can say top is to top, so 13 is to 13 plus y. Top is to top as what? Bottom is to bottom will work. There we go. Let's cross multiply. 13 times 15 is 5. Times 13 plus y, distribute. What is that? 65 plus 5y. 13 times 15, I'm going to use my calculator here. I'm getting 195. All right, keep solving. Subtract 65. 130 is 5y. Divide by 5. And what is 130 divided by 5? It's 26, isn't it? Yep. So y must be 26. See, if y is 26, 13 plus 26 is 39, and 39 is 3 times as big as 13. That does make the triangle below 3 times as big as the triangle above. All the sides are 3 times as big. There we go. Finally, number 37. So we're doing a size transformation on this one. What are the coordinates of the 3 new points after the size transformation listed above? Size transformation listed above. Okay, so they're giving us the center of the size transformation, minus 3, 0. So that's right there. There's the center. From that center, we're doing a size transformation. Going to find the new K, L, and M. So let's do it. So let's start with point K. And let's move to the point. How do you get there? So you go over 1, 2, 3. That's over 3 down 1, 2, 3, 4, 5, 6. So it's left 3 down 6. So we're going to take those numbers and we're going to size transform. So it's like this is the center of the photocopier, and we're going to size transform. We're going to make this triangle a little bigger because 4/3 is a fraction that's a little more than 1. So we're going to size transform it 4/3, a little more than 1. So here we go. So I'm going to multiply both of these numbers by 4/3. Well, that cancels, right? Because it's 3 over 1. So you get 4 there. Now we do 4/3 on this one. And so 3 goes into 6. 2 times 2 times 4, 8. So that means so now we're going to change 3 and 6 to 4 and 8. So from this center now we're going to move, instead of 3, 6, we're going to go 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Right there. That's going to be the new K prime. See what happened? We moved 4, well, I don't need to write them again. We moved 4 and 8 instead of 3 and 6. So you just take the movement left and down that you had to the old point K, and you multiply them both by 4/3, because that's the size transformation. We're making everything 4/3 as big as it was before. So I multiply them both by 4/3, and 3 and 6 become 4 and 8. So now I go left 4, down 8, find my new point K prime. Now what's his coordinates? I mean, from the origin. Can you tell that's like back 7, down 8, isn't it? Back 7, down 8. That's the new coordinates of the new point K, the K prime. All right, let's do the same thing for L and then M. So coming back. So again, from the center, back 3 up 0. Let's do L. How do you get to L? Well, you just go down 3. Straight 3. You don't go over at all. So then multiply that by 4/3, because we're making everything 4/3 as big. So how do we simplify that? Remember, the 3 is over 1, whole numbers over 1, cross cancel, 4. So instead of going down 3, now we'll go down 4. So 1, 2, 3, 4. There's the new L prime. You start from the same center, the back 3 up 0 center, as they said right here. But now instead of going down 3, you go down 4, because we're multiplying all the movements by 4/3. So there's what's the coordinates here? That looks like it's the point. Back 3, and this is what? Down 4. Back 3, down 4. The coordinates of the new point L prime. So we've got that. And now finally we're going to do M. So now for the M, starting from the center, -3, 0. How do we get to M? Back 1, 2, 3, down 1, 2, 3. So 3 in that direction, 3 in that direction. We multiply both numbers by 4/3. We're multiplying everything by 4/3. So you know how to work that out. This is 3 over 1, cross cancels 4. So again, multiply by 4/3. This is 3 over 1, cross cancels 4. So instead of going back 3, down 3, we go back 4. So now we're going to go, let me get a different color here. We're going to go back 1, 2, 3, 4, down 1, 2, 3, 4. There it is. There's the new M prime, right? Let me put a dot right where it's at, right there. See how I got that new point? So before, to get to the original M, it was left 3, down 3, but then I multiplied both those by 4/3, and it becomes left 4, down 4. Left 4, down 4. So there's the new point M prime. Now, what are the coordinates of that point from the origin? Well, what's that look like? -7 and what's that? -4. Yeah. -7, -4 is the new coordinates from the origin. Let's connect them up. So I'll try to put them all back in here now. So -7, -4. There's the M point. And -3, -4. There's the L point. And what was the original K? -7, -8. -7, -8. There we go. Boom, boom, boom. There it is. There's the new triangle. And here's the original center. And you see how we just expanded through? It's like a projection, isn't it? It just goes right through all the old points, and it goes just a little bit longer. It's 4/3 as long. It expands all the old points to the new triangle. There it is.